Hey everyone, welcome to the Fortify mold design training series. Today we're going to be covering module 4, so that's going to be advanced mold design. A large portion of this module is going to be spent talking about inserts, different kinds of inserts, how to use the inserts, when to use these inserts, but in general, inserts they're a tool that we love to use with our mold designs, and they really enable us to do some powerful things in a very agile and cost-effective manner. Besides that, we're going to talk about our ejection strategy a little bit, and we'll touch on one other tool that can be very powerful to really open up how you can use your given pocket sizes for parts that you might not think you can fit. So we'll jump right back into the CAD that we're working on with module 3. So we'll go over to our mold core here. So like I mentioned in module 3, this mold is designed, but you can't actually mold with it. And that's because all the threads on this insert here, they're undercuts. So this part itself, it can't be ejected from this core section with just standard ejector pins and a straight pull. We actually need to unthread the part off of this insert. So at Fortify, we like to attack that by turning this threaded section into a removable insert so that you can inject your part on the machine and then eject the part off the core off the machine. So that really enables you to be ejecting a part while you're shooting your next part and really speed up your cycle time during this molding process. It also allows you to avoid kind of really cost ineffective options of different metal cores that have all sorts of bells and whistles, but they don't really marry well with the kind of prototype and philosophy that we have, being agile and getting parts quickly. So to design this insert, we're actually going to save this part out as a new copy. But first, we're going to make one cut on this part. So we'll do a parting line sketch here. And we want our insert. We'll copy this line here. So this line, this is going to be our reference point for our insert itself. So go, okay. We'll extrude this as a surface. And boom. So at this point, we made the cutout for our insert itself. What we're going to end up doing here is saving this part as a copy. And what this is going to allow us to do, and we'll name this our mold insert. The capitals off. So what this is going to allow us to do, okay. What this is going to allow us to do is have a reference for where the insert is going to go. So we're going off of the same sketch itself for designing this insert. And that's just going to let us know that the insert's in the proper position. It's going to fit properly. We're not going to have any issues during the ejection portion of this molding process. So we'll go ahead and edit the sketch we previously made here. And we're not going to change anything with this existing hole pattern, but we're actually going to add a rectangle around the full part here. And what that's going to allow us to do is cut away around this insert. So here, this is going to be the insert that we actually eject during the molding process. There's a couple ways to design these inserts, but for threaded inserts, one thing I like to do is I like to add a little hexagonal pattern on the back side of the part itself. And this allows you to use, a simple hand tool to actually eject this part. And it just makes that process a lot easier on the user itself. So we'll go ahead and sketch our hexagon. Dimensions. Okay, so we have a hexagon. Put a circle around this so we can cut it away. We'll extrude this. Let's go. So I like to go about halfway between the base of the part and the base of the insert. That's going to give me the most kind of, we'll call it meat on the insert itself to use a hand tool on while still maintaining the structural integrity of the insert itself. So we'll go with 10 millimeters for that. That seems like a pretty equal split. So there we go. We have our hexagonal pattern here for our insert. We'll go ahead and actually we'll jump back to the other core part here. So right now, this insert is designed as a line-to-line fit with our core feature, or with our outer core block. So what we're going to do is create a small offset here. So this isn't going to change the geometry of the molded part itself, but what this is going to allow for is a good fit between the insert and the mold block itself. So we'll take the back side here and we'll add in, get that feature, we'll get an offset on this hole. So I like to use a 76 micron offset. And the reason for a 76 micron offset is our pixel size is 75 micron. So in order to effectively remove a pixel or create a pixel of separation between our insert and our mold block itself, I like to go just 1 micron above our pixel size so that I know that I'm getting that pixel of separation all around this insert. So we'll extrude this feature here. Okay. We'll merge those two together. Okay, so just show that close. So you can see the radii here slightly moving, just slightly. And all that is the offset that we applied. So that'll be enough to get our insert to fit properly. The next thing we're going to go ahead and do here is add a little draft to this area as well. So the reason for adding this, actually I'm going to need to add a plane first. So I need to add a plane in as reference for this draft, but we'll go ahead and add this draft. But the reason for this draft is just to allow the part or the insert itself to eject properly during the ejection portion of the molding cycle. And what we're really looking for is a nice safe draft on here so that this insert doesn't stick at all inside of the core. We want it to come right out during that ejection process so that it's not going to add any time trying to get the core to eject. So 5-degree draft is usually good enough to satisfy that requirement. We'll go back to the insert here and we'll actually add that same draft to the insert. So go 5 degrees, not 55. So let's see. I need to add that draft in first. The actual hexagon pattern that we added in is actually preventing us from properly adding that draft in place. So we'll go ahead and add the draft first. Go 5 degrees. Okay. And then this should be, go ahead and adjust our sketch a little bit. Oh, I see. These are all referencing that. There we go. Now we should be able to do this properly. 2 more. Okay. References. This last one here. Okay. Much better. So you can see that we still have our draft on the insert. We have our hexagonal pattern cut out here. We'll actually smooth that out with a little radii. Go with 1 degree on here. Like I said, this insert itself, this is something that we're going to be able to use for a number of shots because we're going to be ejecting off the machine. We have this nice hexagonal pattern to use, and I use a adjustable wrench to remove this part with. Okay, one more here. That radii is a little too big. Perfect. Okay, so we have our insert. Let's get that last radii if we can. Perfect. Okay, so we have our insert. We've broken the sharp edges on this insert, but this insert, if we come back to our mold core itself, it's going to slot nicely into this core, but we have no orientation for this insert. So what we're going to end up doing, or what we're going to go ahead and do here, is create a key feature for this insert so that we know every single time we put this insert into place, it's going to properly fit into place, essentially. So take a front view of this insert, show our sketches, show our planes. Okay. So there's a couple ways to create this key feature in order to allow this insert to slot properly into position. What I typically like to use is just like, it's not a pin and slot feature, but it's kind of a post and slot, something like that. But what it's going to do is just make sure that we're putting this insert into position properly every time. So we'll go ahead and sketch on the bottom face here. Bottom face. And we're going to use our runner as kind of our guide for this. So we know that when we go ahead and add this to the actual core itself, that we're going to be doing it in the same position. So we'll just create a generic kind of square pattern here first. I'd like to center this on the face as well. That way, that way we know we have good alignment. So we'll make this feature, we'll go, okay, 8 millimeters. So what this is going to do is this is going to give us a nice heft to this feature. It's going to make it very robust while still, doing its job. And we'll make this 15. We can use a pretty arbitrary value there. And we want to make sure that this key feature is really, working properly. So we want to make this pretty deep into the part itself, so there's no chance of you accidentally pushing the insert into position. So with that, we'll extrude this cutout. Go with 8 millimeters. We'll merge that together. So we now have this nice key feature on our insert. Let's go over to the core section itself and we'll design that same key feature. So we'll do a sketch here. So we use this same line here on the insert itself. So we'll go ahead and use this again as our reference position. So for the key on the insert, we made that 8 millimeters. For this feature, we're going to have to actually undersize this feature so that we get a good fit between the insert and the outer core block itself, while still, actually using the key. So instead of 8, we'll go with 7.5 millimeter. Go with I see. Go with equal first. Now we can do 7.5 millimeters. Perfect. Okay. So lock that value. For the insert itself, we went, I believe it was 10 millimeters deep into the part. So we'll go with a 9mm offset. We don't need to have a tight fit between the face here and the actual insert itself. So we're going to leave a whole millimeter of clearance there so that we don't run into any sort of interference issues. Okay, and in a similar fashion, we're not trying to constrain the height, we're just trying to constrain the rotation. So instead of an 8mm extrusion, we'll go with 7mm. So we leave ourselves with some extra space. Go ahead and merge these two together. Perfect. So we have our key feature. So now that we've designed that, let's jump to our mold assembly. We'll make sure that we designed everything to spec. So we'll go ahead and assemble. We'll add this insert feature into our mold assembly. And since it's a copy of this mold block, we can use a default placement here. And that's going to allow us to see, so there was a little mismatch here. We were using different faces for the length of this insert, but we can fix that in a moment. Let's take a quick section view here. So we can see we have our millimeter of clearance in the height, and we have our, should be 1/4 millimeter of clearance on the sides. So we'll just double check that real quick. And yeah, we can see we have our 1/4 millimeter. So let's go ahead and update this. So we actually don't have that line for reference here. So we'll just go with 11mm, get it a little bit closer. But again, we don't need to constrain on this end face. So if we come back to our assembly here, perfect. So we have our key feature, and this feature, it's pretty beefy. So it's going to be a very robust feature for us. We're actually aligning this insert into position. So the last step on this feature is we'll add in, actually on the insert itself, we'll replace the rounds that we had in position before with some new rounds. Don't want to get that area. Perfect. Okay, so we have our key feature for our insert. This insert is about done. So we'll come back to our assembly, just take one last look here. Looks really nice. So you can see the little offset that we designed in here. That's going to end up being almost a line-to-line fit as printed. But for the CAD purposes, it looks a little larger than what you'll actually see off of the printer. So at this point, we have our core and cavity block. They're designed. This is now a functioning mold. We're going to touch on our ejection strategy here. So for this part itself, it's not a straight open and close tool. So we're not really going to bother with ejector pins on this particular part. What our strategy is going to be, and I've talked about this a couple times already, is this part we're going to do a hand ejection process. Since we're going to be ejecting the part off of this core by hand, we're going to automate, or we're going to turn this into a fully manual process here. So what will happen is when the mold opens up, when the mold opens up, I'll show that for a moment. Your part is going to be on your core section, and you're just going to pull this part off of the core by hand. So that really, again, since we're doing a manual process with this insert, that really makes the most sense to just keep everything manual, keep it simple. What we could do with this part, though, is I'll show a sketch. We have some ejector pin locations on this backside here. So we could actually use some metal pins to press our insert out. For this part, we have ample draft. There's really no need to add something like that into the mix. If we were running with something like a polycarbonate or an Ultem, I would want to use these pins to push this insert out. Those materials tend to be a little tougher to manually eject. But for our purposes, a manual ejection process here is going to be fine. But it's very important to make that distinction during this design process, because once you have this mold block printed, it's not something that you can easily adjust without having to print another mold block. But so that is the ejection process for this mold block. If we didn't have these threads and this part was just as is without the threads, then we'd really want to get into trying to place the part in our master model. So we'll come back to our master model here. Trying to place this part so that we have ejector pins positioned right on this base edge here. That way we can actually push the part out of the mold block itself. But again, not really a consideration for this mold block. And the last thing I want to touch on here is the not the raised parting line, the offset parting line. So the offset parting line, that's a tool that for an awkwardly shaped part, depending on your gate location, it's really could be a powerful tool. So if we come back to our master here, this part itself, we selected this as our parting line. If we selected this base edge as our parting line, we'll go ahead, actually, I'm not going to be able to show that here. But if we selected this base edge, our part height itself would not allow us to satisfy. So it's 25.375 millimeters. If we show our planes here, from the rear of our A block to our parting line, we only have 31.75 millimeters of space. So if we use this as our parting line, then if we use this as our parting line, we wouldn't have enough space between the top of this part and the back of the A block in order to fit this part. So we would actually position the part the same way that we have it, but instead of having our runner section come into this top face here, we would have our runner come at an angle down here, and it would actually change the parting line, not the parting line on the part, but the parting line on the mold block. So instead of being right on the center of the mold blocks, it would be offset and biased towards the rear side of the B half. So really what this allows you to do is adjust your gate location of the part and fit different parts into a smaller size than what you otherwise might think possible. So just to recap here, we've identified the feature that we need to turn into an insert. We effectively turn this into a usable insert, a functional insert that is going to allow us to properly mold the part and eject the part without any sort of issue. For our cavity half, I'll hide that insert as well. For our cavity half, there's no undercuts on this feature, so it does not need to be an insert. Although this geometry, you'll find a lot of inserts that look similar to this geometry, but we've identified the insert, we've created that insert, and we now have a functioning mold that is something we could put into our machine and successfully mold parts. There are still some more features some more tools that we like to use that really improve the quality of the molded part. So things like limiting flash, more effectively using your clamping tonnage, things like that we'll touch on in our next module. But for today, we have our mold block and it's ready to run. I'm pretty happy with how the design turned out. So thanks everyone for tuning in, and be sure to tune back in for module 5.